LinkedIn echo chamber. This is ML's like team spirit. Will is back. Will, how are you doing?
Hello again, John. Very good, thanks. And
Hello
yourself?
again. You're not sick of me yet.
Not sick of you yet, no. But
Still in
I'm
live
never
in
sick of
Bristol.
hearing the sound of my own voice talking about data science.
This is nearly over, but I wanted you to come back and speak to us, Will, because you've got an area of knowledge about a type of data structure that I've been wanting someone to come and talk to me about, so that we can take people through it. So I wanted to talk about knowledge graphs with you. Um, and I'm wondering if the reason that I wanted to do that with you is you might be one of the first people to ever talk to me about knowledge graphs.
Okay.
Well, well, I've known you 18 years, I think, or some scary number like this. I can't really remember now. Um, but 18 years ago, I would have been a bright young thing. Now I'm all battle scarred and old. But you would have been talking about things. In fact, you definitely were. So, Will, can I just leap into your background? Remind me, when you studied a master's or something, you were in the space of biology or something crazy like this. Can you remind me of what memory I've got there?
Yeah, so I did a master's and it was the title of the course was Evolutionary and Adaptive Systems.
That
And it
sounds
was
like
kind
it.
of
Go on.
yeah, it was a small department at the University of Sussex where people got quite geeky about evolutionary algorithms. Um, and I have to say that most of what I learned there were kind of ironically evolutionary dead ends in terms of machine learning, but it did at least stimulate an interest in the subject.
Well, it did with me because I never forgot you explaining it. So I think you were talking about evolutionary genetics and crazy things that I had never heard of. And now,
Yeah.
even though my recall is sufficiently lower day to day, now that my children have arrived, all those years ago, I had a razor sharp memory. And I remember you talking about knowledge graphs, which was this kind of data structure that was emerging. So I wanted to do an interview about that, really, because it's something I think that data scientists recognize as it's a data structure that fits certain use cases, and it
Mm-hmm.
can be helpful in certain ways. Um, and I think the reason I want to do this, I think pretty much everyone has been, even on a daily basis, people are probably within a knowledge graph on several different occasions through their day,
Mm. Yeah.
but maybe don't recognize it. So I wondered if you could tell us about like what they are, what is interesting about these structures, and then we're going to meander through the rest around some typical use cases and really how their use has evolved probably over the last 20 years. But take it away, Will. What is a knowledge graph?
What is it? What is a graph, in fact? So I guess the first thing to say is that when we talk about a graph, we normally think about an X and a Y axis and a wiggly line across it. And that is not what we mean here. What we're talking about is a mathematical graph. A mathematical graph is a way of representing data where we're really interested in the relationships between our data points rather than on the features of each data point. So if I've got an Excel workbook and I've got loads of rows and loads of columns, I've got a tabular data structure. And in that, I'm thinking about, well, each row here might be an example of something, a transaction, for example, and then I've got all the bits of information about that transaction. Whereas a graph representation would say, here's a transaction, here's another transaction, and I'm going to connect the two transactions. Let's imagine 2 points with a line between them, which we call an edge. And that edge is going to represent the fact they were made by, for example, the same person. So a graph data structure is a way of representing data where we focus on the relationships between our data points rather than on just the absolute values of all of the features of each data example.
I've just remembered I have a knowledge graph visual. So, ladies and gents, if you saw the beginning of this video, as the intro rolls, a knowledge graph makes its way across the screen. So, rewind, start from the beginning, see what the knowledge graph looks like. So, it looks like interconnected data points. The actual data points themselves and those connections can have all these different values, which is what makes them interesting to a data scientist. But I should let Will explain this. So, Will, what would be like? Let's pick on a couple of use cases. So people can kind of get a good intuition for it. Where would be two really big use cases? So pick two. Where would be two really big use cases for a knowledge graph?
Yeah, so I suppose we could say the most obvious one is that an online social network, of which we've probably all used many of them, has underneath it a set of communities of people who all interact with each other. And so we can think about that as being a graph where the people are our nodes or our points, and the connections between them might be the fact that they interact or they follow each other or they have a friendship or whatever that particular platform um, decides is a relationship between them. and that is a social graph underneath. We can model that as a graph data structure. And I guess another big area where they are used is in fraud detection and information security. Okay, where we can think about, let's imagine we're a bank, and let's imagine we have an enormous IT estate filled with computers, filled with people, filled with email addresses, filled with IP addresses, services, things like that. We can imagine building a model with all of those things as being our nodes and relationships between them being that this thing accessed this other thing, or this person this used this account at this time. And we can therefore model the relationships between all of the bits of computer hardware and all of the accounts and things that live within our infrastructure walls. And that's actually a very useful way to think about this thing if what you're looking for is the oddities, the unusual relationships, the strange things. So those are two big use cases.
Let's pick on the social one. So, on prior interviews, Will, you've very carefully explained to me how business outcomes are very important for data science. Um, let's do the social network one. So, they've got a graph of interconnected people. Um, the nodes or the data points might be Will and John.
Mhm.
There's something that connects us both. What services might the social network be building off, on top of this data structure? How might they be utilizing, that you and I are connected? What might they be seeing, and how might they build it into their offering, or what I see when I'm scrolling around? Like, what could be an example there?
Well, let me give you two examples. So, 'cause the first one relies on a principle called homophily, which was discovered in the research like 50 years ago, and essentially it means that birds of a feather flock together. So if you represent your social network as a graph, you'll find that what you will tend to get is very tight clusters of people who all speak to each other but don't really speak to anyone outside of that circle. And there's a technical name for these clusters. We call them communities. Okay. Now it so happens if you understand the people in a community, the content they pass around between them, then you can understand uh, what they're interested in. And so you could understand how to fill their timelines because they're probably going to like the same kinds of content as other people within their own filter bubble. Now, actually, optimizing people's news feeds for this causes its own problems. It essentially reinforces the viewpoints and the news and the conversation within a particular bubble, but it does mean that you get more eyeballs on the screen. And so there's a kind of a tension in building these products, which is, do you just create these problems by reinforcing what people within a particular community think and see and how they act, or do you try and spread the discussion and introduce them to new viewpoints, knowing that it's probably going to lead to a less compelling experience for them? So there's a fundamental tension there at the heart of how these kind of recommendation engines work in a social network. And I guess the
Uh,
second example would be that you can see behaviors across these networks that might be coordinated, that might tell you that somebody's trying to push misinformation, or they call it astroturfing. So in a graph representation, you can see these things much more clearly where people are trying to impact the network and flood it. You can detect it and you can start to do things about it. So those are two ways that this representation really helps.
Yeah, it's very relevant. That second example is very relevant to today's world, and I'm thinking back to our friend Nandu, who's always thinking about the echo chamber and how that becomes self enforcing. That it's that
Mm,
community part. I guess I've got a 6-year-old boy, and the recommendation engine side is why I keep getting Transformers Generation One toys groups recommendations. It's not because I've regressed to being a child again. It's I must be doing things with my son and looking at other pages and yeah, I'm not ashamed to say that I now join those groups and follow them with a great passion. So at least on that,
fantastic.
at least on that side, the knowledge graph is working effectively um, for Facebook. I suppose I'm old using Facebook, but anyway, don't comment on that. Um, well, I've got another one that I remember. Would you believe it? I actually worked on some of this. So another use case, knowledge graphs in natural language. So I worked on a project years ago with biology data from natural language. There's a discipline in biology called indication expansion. It's about how do you try and repurpose medicines and drugs
Mm,
to different diseases based on common characteristics. So this is an extra one of like how do big pharma figure out that drug Y might be suitable for disease. They call it an indication, but some type of problem. And the big one that came from this space very quickly on the COVID outbreak was hydrochloroquine. Trump famously announced it at an early speech about the COVID pandemics.
Mm.
But it came from natural language processing and knowledge graphs. So as an indication of one that just like a single data point discovered that way that became almost universally known, within hours of Trump announcing it. That's just another one people could think about as to what
Mm.
comes from a knowledge graph. But expand this for us, Will. So I understand then that it creates an interesting structure. It helps us with interconnected data. How has this all advanced? So I'm asking. This is a loaded question. I know that in the last 3 years, this has just blown up again. So it kind of was interesting when knowledge graphs came out and social networks came out was the obvious one. And I feel like this is getting hot again. So what are some of the key things happening there, or some of the innovations around it? And maybe again another use case perhaps that you could think of so that people can recognize it. Like what's really going on in this space that's hot right now?
Yeah. Well, I suppose like everything in data science in the last few years, it's become all about deep learning. And it wasn't natural at the beginning to think about how you design a neural network that can operate on a graph data structure. But it turns out you can. And it turns out they're extremely powerful at understanding graphs and making predictions around them. Um, Let me give you a slightly oddball example, but that I hope kind of shows you the power of these things. Um, let's imagine something like you have a solar system and you've got a load of planets moving around. Okay, we can think about that as a graph, right? We can think about that as a graph because we've got a bunch of nodes, which are all our planets and maybe our star, and then we've got relationships, which is the gravitational influence that each one has on each other one. Okay, why is it useful to think about that as a graph? Well, because although the equations exist to help you predict the motion of the planets and which ones are going to interact with which other planets, and are they stable or are they not, they are enormously complicated, and you require a supercomputer to try and actually solve these things. Well, it turns out that graph neural networks do an extremely good job of explaining and predicting the trajectories of systems like this. And we can apply it to, once we have that insight that we can model things in the physical world as a graph, and that a graph neural network can help us predict the evolution of the system, we can suddenly see this enormous vista of opportunities for applying it to things that aren't just social networks or computers in banks or collections of web pages. And so that's one of the reasons that there's a lot of excitement about them at the moment. We've got a new technology to help us process them.
God, so we'll be seeing more of this in the next years then, Will. So look, that's a great point to finish on, Will. We're about to hit time. I guess what I'm hearing is that there was this novel data structure over here. Hang on, let's just do this, Will. Novel data structure over here, coming from social networks and network models, algorithms over here, neural networks expanding into multiple layers and deep
Mhm.
learning, and we've got a collision. And you're saying we've got the whole new discipline and capability in front of us. So actually, this is just an indication
Yeah.
of how data science is always moving, um, and it's always such an interesting space to be. And now we just have to see what the fruits of that are.
Yeah. And I suppose I would leave the listeners just with one comment, which is that, if you're a data scientist or if you're working with a data set, maybe ask yourself, can I think about this as a graph structure? And if I think about it as a graph structure, how does it change my view of the problem and how I might approach it and what ideas I might have for, whatever I'm trying to do with it? To have that at the
Yeah.
back of your mind. A lot of things can be represented as graphs, and sometimes it can be a really good choice.
Um, hashtag ad. Marketers of the world, I use graphs very frequently to cluster content together into who likes which consumers like which type of content. So if ever I go into data science talk about how do we identify sending customers more of what they prefer, knowledge graphs are sometimes at the heart of that. DM me to find out more. Will, thanks for teeing me up for that ad. Thanks for your support. Thanks for being here, ladies and gents. This has been ML's Like Team Spirit.